Hello, everyone. Welcome to today's webinar with NCFI Geotechnical Division. The webinar is going to be, kind of like an intro webinar to geotechnical polyurethanes, a semi sort of 101 type course. Next slide, please. Can you go back to your slide real quick?
Yep, sorry.
All right. Well, can't be a webinar unless you have a few little technical knocks. So anyway, I'd like to introduce you to Tom Gibbs. Tom Gibbs is the National Sales Manager for the NCFI Geotechnical Division, and that's a division of NCFI Polyurethanes. As you can see, Tom's got a pretty robust resume in regards to the application of structural polyurethanes. He's been in the industry for 16 years. I've been working with geotechnical polyurethanes since 2007. He's worked at all levels, from shooting a polyurethane in the ground all the way up to sales to owning his own business and then operating in the current position he has now. And Tom used to also serve as the former lead of Keller's polyurethane grouting division. Next slide, please. So a little bit of housekeeping before we get started. The approximate length is 1 hour. There is chat that's available to ask questions. You can see that in the dashboard of the Zoom window. We will provide a recording link after the webinar. And then there will be the Q&A session will be at the end. Next slide, please. In order to ask a question, you'll see the Q&A button. It's a little different icon than this previous image here, but the Q&A question, feel free to ask questions throughout the webinar. For efficiency purposes, we won't ask till the end, mainly because it's, I'm sure many of you know it's pretty tough when your cadence is interrupted as far as the webinar, and we're going to be covering a good bit of material today. But click the ask question and then enter your question and send. We'll take a tally of the questions and we will ask them at the end. We're going to try and make sure that we leave enough of a time gap at the end of the webinar so we can cover all the questions, in respect of all of your time. And then we'll go over the time to continue to ask questions for those of you still interested post. Another note real quick is the webinar, anybody here that's looking for a PDH certificate, the PDH certificate will be distributed after the webinar, but there will be a poll, a survey that's at the end of the webinar. Please fill out that and indicate within that poll that you would like a PDH certificate, and then it will be distributed to you. If you accidentally click off the window at the end of the webinar, a follow-up email from Zoom will be sent that'll also have that survey. So just make sure if you want a PDH certificate, please fill out the survey. If you don't want a PDH certificate, please fill out the survey anyway. It helps us really maintain the quality of these webinars and also future subjects that we may cover that may be of more interest to you. So that being said, housekeeping's done. Tom, take it away.
Thanks, Robert. Appreciate it. So just a little bit about NCFI Geotechnical and NCFI Polyurethanes before we get started. NCFI was established in 1964. We're a division of Barnhart Manufacturing, which was founded back in 1900, based in Charlotte, North Carolina. We have 2 production facilities, one in Mount Airy, North Carolina, and one in Houston, Texas, or Missouri City, Texas, to be more precise. The main headquarters being in Mount Airy. A little bit about the division. The Geotech division specializes in polyurethane products for civil and soil stabilization applications. NCFI first developed polyurethanes for concrete lifting and void filling back in the early 1990s. Today, we have over 25 different geotechnical polyurethanes that have been developed for various applications and markets. Some of the benefits of geotechnical polyurethane grouts. So they have extremely strong structural properties for what people think of as a foam. They're going to be harder than the dirt that they're replacing. And in just about every case, the structural properties tougher than dirt. So minimally invasive, fast cure times, zero excavation, an environmentally inert product, Aesthetically, you have with the projects, you have no impact of surrounding landscape, no grinding of concrete required, smaller project footprint than a lot of traditional grouting methods, and a small carbon footprint as well. We're going to start off with just some chemistry basics to kind of get everybody up to speed on that's unfamiliar with it. NCFI makes a couple of different types of systems. We'll start with the dual components. With our dual component systems, all of our A sides are going to be the same product. So it's MDI, which is methylene diphenyl diisocyanate, also referred to as ISO. But with all of our dual component systems, that product's going to be the same throughout. The B side or resin is kind of where the magic happens. And that's a combination of polyols, catalysts, blowing agents, etc. With processing this, we use proportioners, guns that are specific to the industry. The proportioners both keep them on ratio as a 1-to-1 ratio, as well as heating the material up to around 110 is what we test at. You can adjust your speed slightly by turning it up a little or turning it down a little. Recommended processing is heated around 110 to 130. Mix using an impingement gun around 1,000 psi. Reactivity. This refers to how quickly the mixture expands and forms a different foam after being mixed. Reactivity can be broken down into 4 stages: the cream time, the gel time, tack-free time, and rise time. So we have fast foams and slow foams, and we have some in between. Fast reactivity is used for pinpoint lifting and control. So if you're doing some concrete leveling, that type of work, real precise work, then you're going to want something a little quicker. It does, however, not spread out as far, so you have to go back through and make sure you fill all the voids. You can tighten up your grid to make that happen a little better. With the slower reacting foams, you're going to get more gradual expansion. It's longer reaction time. We have some that would be considered slow that are still used for lifting. We have some that are incredibly slow that are used for void filling. You're going to get more coverage per injection location, so you can spread your grid out a little bit. Great for large void fills, but not as popular for precision lifting. Density. So the free rise density of our polyurethanes are what you're going to find on our tech data sheets. This is the minimum density as designed by us, the manufacturer. But those samples are unconstrained or unrestrained during expansion. When we're actually applying the product in situ, into the ground, the foam is going to pack in, as we say. It becomes denser than that free rise number. But the good news is with that increase in density is also an increase in compressive strength and other strength values, such as tensile strength and shear strength. So it also increases the force the polyurethane can exert for lifting. So once it's shot in, it fills the voids, it starts to pack in, and then that will allow it to overcome the confinement and begin to exert force or lift. When you're choosing a polyurethane, density is one of the things to take into consideration, and one of the biggest factors when it comes to estimating how much material you're going to need for your project. Higher densities are used for greater load-bearing capacity, so commercial work, heavier traffic on that concrete asset or slab. You're going to want something higher density. Lower densities are great for lighter loads, general void filling. So confined density versus free rise. Right? If you take 8 pounds of a 4-pound system, or what we call a 4 PCF system, and try and squeeze it into a half a cubic foot of space, if that space is tight, it could pack into as tight as an 8 PCF or 8 pound per cubic foot block of foam. However, if the soil is loose and in need of compaction, it will pack into what the soils allow, somewhere between 4 and 8 PCF. The tighter the confinement, the more packing occurs. So my best example here that I like to use is if you shot this into a really well-constructed metal box, it's probably not going to do anything to the box. If you took the same size cardboard box and filled it up with more than with 8 pounds of 4-pound foam, it's going to break that box open. So, selecting the polyurethane for your project. So why do we have so many lifting formulations? I mentioned earlier, we've got over 25 different systems, and there's a reason for that. Is what we're talking here. This is a good example of a foam that was not selected properly. As you can see, it absorbed quite a bit of water. We have some systems that are not considered hydrophobic or hydro-insensitive. Those terms kind of go hand in hand, but essentially hydrophobic foams are going to displace the water instead of absorbing it like what happened here. So we have different geology, presence of water, soil types, different applications, different weights and densities that we need to use for different applications. Dual component systems. This would be our terrathane and our stratofill line. The dual components in the terrathane line would be your lifting systems and some void fill systems. There's system specific reaction speeds. So we have some that are really fast, like I mentioned earlier, and some that are slower, higher compressive strengths and lower compressive strengths, hydrophobic and non-hydrophobic. They all have a verifiable minimum density. That's your free rise density. They can be used for soil stabilization, undersealing, deep soil injection. These are the things that help us determine which one we're going to select for a particular project. The stratofill line is our lightweight fill line. These are lower density systems. They're going to have a lower exothermic reaction. So they can be placed in thicker lifts, not necessarily as big of a concern with the exothermic reaction that occurs when foam is being created. If you place a really dense foam that's not considered low exotherm and too great of a volume, too thick of a lift, it can literally catch on fire. So we want to make sure we're using the right system for large void fills. And then we have the Terralock line, which are single component systems. Not really used for lifting at all. It's more of a permeation grout instead of like the dual components act more like a compaction grout. Lower viscosities so they can soak into the soils. And with single components, you have both hydrophobic and hydrophilic systems. We're not going to go into that a whole lot today, but there's various uses for those two different types. Soil stabilization, water stop or crack injection grouting are some of the things that are done with the Terralock systems. As you can see in the picture there, quite a bit of seawall repair, bulkhead repair being done with these types of products. The single component systems, there is a little bit of a misnomer to the name. The single component can be used without any additional catalyst package, but you can add additional catalyst to the system to speed up the reaction time. This is an adjustment that we don't really have the benefit of with the dual component systems. We can't just add something other than heat. But with the single components, you can add up to 10% additional catalyst to speed up the reaction time based on what you're trying to accomplish. The last component being that moisture needs to be present for that's what actually kicks it off. So moisture needs to be present in the soils for the reaction to occur. With the single component systems, the catalyst is added right before the product will be used if you're going to add any. The equipment does not have to heat the material up. However, the colder the ambient temperature is outside, the thicker the material is going to be. So you do want to make sure you're keeping your material warm prior to installation. You would mix the catalyst right before pumping, inject with either an airless sprayer, diaphragm pump. Some systems for smaller projects would be put into caulk tubes for use. Again, water or moisture does need to be present for the chemical to react. So the differences between them, higher expansive pressure with your dual component systems, low expansive pressure with the single component, therefore no lifting. The system specific speed, with the dual components, you have a little bit of control with heat, but not much. With a single component, you can speed it up quite a bit by adding catalyst. The dual components are going to act more like a compaction grout, pushing the soils out of the way and compacting them, whereas the single components, when it comes to shooting into the ground, are going to be a permeation grout. You have a certified minimum density with the dual components. Density is going to vary with what you're shooting into, the soil matrix you're shooting into with the single components. Standard viscosity with the dual component, really low viscosity with the single component. Again, we have hydrophobic or non-hydrophobic with the dual component systems. With the single, we have hydrophobic or hydrophilic. And so some of the crossover applications, there's some things that you can do a little bit of both with. Water cutoff can be done with both. Void fill, not quite as much, much smaller voids when it comes to the single component. Ground stabilization, undersealing, soil densification. So we've talked about reactivity, we've talked about density, but when picking a polyurethane, probably one of the most important things is the project goals. So what are we trying to accomplish? Are we lifting slabs and realigning them? Are we filling large voids? Are we densifying soils just to try to increase load bearing capacity? So, in talking about, selection, that's something that we're here to help with. We have a lot of different systems, but it's not one of those situations where you're going to have to stock and keep all these different systems on hand if you're a contractor. A lot of projects can be accomplished with some basic systems that most guys stock. So talking about the injection approach, where do we start? We want to develop a plan, gather and interpret all the information as we can get. Soil information is important when we're talking about doing anything beyond just lifting at the surface when it comes to concrete leveling. So how complex is the job? Is the slab a good candidate? Is it, broken up too much, or is it in fairly uniform shape, but just needs a little bit of adjustment? So when we're looking at design for approach, we look at the slab sizes. We're going to try and come off the edge a little bit because you're going to get spread. So you want to be about a foot to 18 inches off the corner or at the edge. The faster the foam, the smaller the grid pattern you would use. So a 3x3 for one of our faster foams, maybe a 4x4 for a slower reacting foam. And we've gone bigger than that, sometimes 5 feet. And they need to be adjustable in the field. When designing one of these programs, if an engineer does get involved and wants to be particular about, how it's written up, sometimes in the field you find out that it's just not working the way you wanted it to work, or that you thought that it would. And so field guys need the ability to make those adjustments in the field. Identify where the lowest point is and where the void likely exists, and start there and work your way back out. Drill your holes with appropriate spacing to the design grid pattern. In some cases, you want to pre-drill most of your holes. In some cases, you may want to wait. Again, starting at the lowest point. Inject there first. As lift occurs, voids will form in the center. We need to make sure we get back through to fill all those in, especially when we're using faster foams. We want to make sure that we get full coverage underneath the slab so we don't have any voids. Deep soil stabilization. So this is a little bit more advanced stuff. This is where we're going to need to have the soils information in order to design a proper solution. What we're trying to accomplish with this is similar to compaction grouting. We're trying to densify the soils at depth. We rely on the expansion of the polyurethane instead of the pumping action of the actual concrete pump. But with this, we're placing the material on the ground, allowing it to expand and push the soils outward and upward and downward. It's a more complex and costly approach than just typical lifting. Requires significantly more detail about the soil density and voids. So again, soils reports are very important here. Estimating this is a little more detailed. It's higher labor costs and equipment. Oops, sorry. Getting the pipes in the ground, so drilling sometimes is necessary. Estimating how many pounds per injection based on the soils reports. So highly recommended that these projects have engineers involved, or at least engineering information involved. So with deep soil, typically we're going to do anywhere between 3 to 5 foot grid spacing at the surface, as well as with our pipes shooting down. So you're going to, if in some cases, if it's shallow enough, sometimes you can inject it at the base and pull your pipe up. But we typically do this from the top down. So usually you're placing more than one pipe per injection location. Injections are typically, again, top down, can be done from bottom up depending on conditions and desired end result. The below soils are now denser and more compacted. Polyurethane on the next injection level will now pack in, pushing down on the uncompressed soils below. Final injection, the unconsolidated weak soils are stabilized and compacted. Your overall load-bearing capacity of the soil is dramatically increased. Different applications for deep soil stabilization would be reestablishing soil support, void filling. If the report is showing voids in the soils, slab lifting and leveling, grout curtains, slab stabilization, increasing slab load bearing capacity, and cap grouting. So the different types of applications that contractors are using these products for in the residential market: foundation slabs, driveways, garage slabs, pool decks, sidewalks, and steps and porches or patios are all very popular residential type applications. The commercial applications range from foundation slabs to drive lanes, trip hazards, rocking slabs in warehouses, pre or post design stabilization for increased loads, and then infrastructure repair. Transportation applications include roadway lifting, airport runways, bridge abutments, rail bed stabilization, drive lane stabilization, and again, more infrastructure, culvert and sewer stabilization. Industrial applications would include trench breakers in the oil and gas industry, seawalls and ports, infrastructure work, rail bed stabilization, slab lifting and reinforcement, and again, trip hazards. Talk a little bit about seawall repair real quick. Fast and effective seawall repair, it's really a combination of both single and dual component systems that we use here for these types of applications. But it's fast and cost-effective solution for rehabbing and restoring a seawall to help prevent future issues. There's all types of different problems that occur with seawalls. You've got voids forming at the surface from the undermining of base soils, or from cracks in the wall that are allowing soils to come out from behind. And so lots of different failures that can be addressed. What causes these? Continuous tidal fluctuation, hydrostatic pressure from behind the wall because of poor drainage, and erosion of support soils. Quick video here. Thanks. So this kind of shows using a single component pump to grout the grounds behind the seawall there. Typically, what's going to happen here is you're going to have some expansion into the soils that's going to help to push the soils out, so you've got good soil that you're grouting. Infrastructure repair is also a huge opportunity for use of these products, both single and dual component. Sometimes when we're doing stormwater work, we can do it from inside the pipe if it's large enough diameter. It can also be done top down from outside if it's too small. When going from inside the pipe, we typically are going to inject in different positions around the pipe, depending on what's going on with it. Sometimes you're able to realign joints, but definitely good for sealing joints and stopping infiltration, exfiltration. Polyurethane reacts and begins to expand throughout the soil and against the pipe. It'll travel after confinement is reached, or can be injected, and then can be injected at 2 o'clock or 10 o'clock if needed. It'll seal the cracks, voids, and restore the soil load-bearing capacity in a single application. As you can see from this diagram, there's all kinds of different, with stormwater systems, all types of different ways and areas this can be used. But basically, sometimes it's not enough to improve the liner of a stormwater pipe. Sometimes there's some large voids that have been formed on the outside of the structure, and those are often noticeable from dips in the asphalt or failure of the concrete above. Different applications include culverts, manholes, joint sealing, lateral lines, void filling, catch basins, utility vaults, locks, and also abandonment, pipe abandonment. We're going to go through some case studies real quick. I tempted not to play this video, but I'd like to. This was an outlet mall in Clarksburg, Maryland, with a major trip hazard problem. This particular outdoor mall was tiered and had multiple different levels of shopping. So this was at the highest level. On the left there, it's the right slab that's actually moving. Sorry, that put the camera on the wrong side there. But on the left side, that is a 2-story structure, which we'll be able to see in this next little slide. So this was a delivery hallway, and this is the lower store. This piece of concrete here up the top right is where we had issues creating that trip hazard. So you had a retaining wall creating a tiered level, and probably wasn't sufficiently compacted against when they backfilled it, causing some of that top sidewalk system to fail and sink. But to keep it from just being needed to be lifted once, they had us do deep injections down into the gravel base to solidify that, and to avoid the French drain. So we had a set level that they wanted us to shoot down to. We did 3 stages, and then we lifted at the top. It was about 1,400 linear feet of trip hazards eliminated on that project. This project was for an unnamed chicken plant, a chicken manufacturer or chicken processing plant, where the floor drains had been compromised and created a major. I'm going to skip over to this next slide. When we looked at this project, this is what we walked into. The drains had been jetted and caused major erosion, which they decided they wanted to replace all the pipes and stuff. So they tore out the majority of the slab, but in some cases, like this structure here, top left, there's a giant freezer there that would have taken months to get out of there. It had to be disassembled and whatnot. So we had access to both ends of that particular freezer, and we're able to use PEX piping to inject it to the middle and work our way out and reestablish contact with the soils underneath from the washout that was caused by the drainage problems. And then anywhere that they didn't tear slabs out, we went through and injected there as well to just to make sure no voids still existed. From the time that they called us on this project to the time it was done was under 2 weeks. They were losing $250,000 a day, so they were pretty happy. This is another application for that was kind of different. This request was to be able to provide on the sheet pile wall a flat surface for the dimple board membrane that the waterproofing company was going to put in. It also helped eliminate quite a bit of weight from the concrete that was poured for this parking structure for this condo complex. So this is a Stratafill product, our 24023, a low exotherm system. So we're able to fill those bellies without having to, slow down and wait for it to cool down. Just some other examples of Stratafill projects that have been done. Again, it helps to lock soils together a little bit. It's not structural necessarily. In this case, top left there, basically on that project, they were having large outfalls of the clay overnight. As the clay dried up, it would fall out and create big voids. But that's not the final wall. That did continue on down with shotcrete, putting mesh over this surface and then shotcreting over that. And they had no adherence problems there. On these other two were more of a rocky face, but it had a lot of ins and outs that they wanted to fill out and kind of level it out. This Whitewater Adventure Park was a Terralock project. It's our single component line. So this going to build a whitewater park here on the Illinois River, and the river was leaking through this massive rock here, and so they injected down through to kind of seal the seams up and stop that exfiltration of water from the river. This is a scour project. This is in Montreat, North Carolina. This was a relatively new, couple-year-old gabion cage wall. There's a road up at the top there. At this particular location, there's a bend in the creek. Can't really see it very well, but a 100-year flood came through, went up as high as where those bags are, and just scoured right up underneath the wall, creating some sagging issues. They didn't ask us to correct the sag, but they did want to stop it from getting any worse. So at the bottom, underneath the portion that's wrapped in geofabric, there was about an 18-inch tall and 3-foot deep scour up underneath there. So we put the sandbags in place and pushed the material through PEX tubing, and anything that came out was caught with a boom a little bit further down creek. You can't see it there, but any material that came out was caught there. So help with that project. On this one, if you want to see the video for this particular project, you can scan the QR code that's on the screen now. This was a contractor, Mr. Level, up in Ohio. This is at Ohio State University. I didn't get to have the benefit of being part of this project, but basically this is their indoor track that had some soil stabilization issues that needed to be done and some lifting as well. Basically led to over $900,000 in savings versus the alternative plan of tearing things up and redoing things. Another one of our contractors, USG, or Utility Services Group up in Pennsylvania. This is a really good example of when this is at a bottling plant. This is a great example of when the equipment used can be, the small footprint of our equipment can be very valuable. USG has a really unique setup where their equipment is able to come off the truck or trailer and be brought in with a forklift. But more than anything else, just getting drills and large grouting equipment back into a tight space like this would be very difficult using any other method. So they overcame tight accessibility issues that way and were able to stabilize with some deep injection using our 24003 system at 180 different injection points. Good residential job, residential pool deck stabilization by Triangle Concrete Solutions. Improper initial ground packing led to the sinking of the homeowner's pool deck, causing water erosion and plumbing issues. To replace it would have cost about 60 grand, tear it out and replace it. So they were able to lift that, stabilize it, and give it a lot more life. Seawall repair, again, this is another one where you can scan the QR code for the video. This one highlights our 24120 Terralock and our Terrapin workstation. The Terrapin is this cart down here. It's kind of a all-encompassing little device that's it's motor powered, battery powered, self-propelled cart that has a generator and the pump and room for equipment and tools as well as grout. And so Florida Marine Builders and Profoam tackled this project together. Good seawall repair job using the single component injecting behind the seawall. Just talk a little bit about NCFI and the advantage of using NCFI for these types of projects. Again, over 25 different systems, 150 years worth of experience on our team between the territory managers and the tech team. We've got quite a bit of experience, most of which is guys that have been behind the trigger for a good number of years. Formula variations are designed to balance both performance in saturated environments, expansion, density, adhesion, reactivity, and spread. Physical properties, you're going to have densities anywhere from 2 pound up to 8 pound or higher in some cases. Not stuff we make on a regular basis, but we do have some other formulas that are even higher density than that. Compression strength ranging from 25 psi upwards to 240 psi. Again, we are not replacing concrete here. We're replacing the subgrade. Flow rates or reactivity profiles can range from a few seconds upward to several minutes. Low exothermic polyurethane systems available for lightweight fill. Our R&D department is great. We have labs at both of our facilities and a great team to help us develop new products as needed. And so in-house R&D is comprised of experts with over 30 years of development experience just in the geotech product line. And then new designs go through stringent ASTM testing. You'll find ASTM tests on all of our data sheets for things like compressive strength, tensile strength, shear strength, compressive modulus, all that good stuff. And like I said, a heck of a support team for project design and technical support, both with the systems as well as the equipment that we sell. Quality control is a big part of what we do at the plants. Testing is conducted on each batch prior to shipment with QC tracking from lab to field. And logistics are optimized for fast shipment, minimize costs, supplier quality control, and polymer quality management. Supply chain ensures optimal polyurethane quality and shelf life. Again, great customer service team and technical service team. We have both in-house and out in the field. The tech team that travels out in the field is out there, getting dirty with the guys and girls in the industry. But we also have folks in-house that take orders for parts, and they're great with the equipment as well, certified on how to help troubleshoot equipment, things like that. And then the territory managers, as well as myself and the rest of the team, can help with project design. If you gotta have a challenging project, you think poly might be a good application, feel free to reach out to us. We're happy to help. And then training. We know that without proper training for our contractors, that they're not going to be doing this right. So we make sure that they're all trained properly and certified, and we keep them up and running. That's about it for this presentation. We will be doing a series of these, and each time around, the topic's going to be a little bit different. So keep an eye out. The next one you hear about will not be the same one. It'll be on a different topic, and we'll put that in the posts. But thanks for your time. We appreciate it, and I guess we'll turn it over to Robert to handle the questions portion.
All right. So we are here. I think done it in pretty good time, Tom. So that's awesome. So I'm going to flow through the questions again. Here's the process for for submitting questions. Please do, but we have a few that we can go ahead and take on right now. So the first question is, Are these used to fill voids in bulkheads? The answer, I think, has already been given in the presentation is a yes, we can. But I think the second part of this question is very relevant, which is, are there any issues with using these in tidal waters in Maryland? Has this been used before? Can these be used underwater?
So yes is the broad answer to that question. One thing that wasn't really covered too much in this particular presentation that I do want to cover is that quite a few of these products have the NSF 61 certification through ALS and Truesdale Laboratories. So NSF 61 is basically the testing that's performed in order to say that a material is suitable for contact with potable water sources. And so essentially you could create a vessel out of this stuff and pour water in there and drink right out of it and not have to worry about leaching of chemicals and things like that. All of the single component products that we talked about today have that certification, as well as many of the dual component systems. We've only certified certain ones that we find that would be used for particular applications. We didn't do all of them, but they're all essentially the same products with slight variations in quantities of different things. So majority of them are going to be safe either way, but the certified material is blended upon request. There is a special process we have to go through cleaning the equipment before we blend a batch of it. But it is safe for use in tidal waters, or don't have to worry about it contaminating. Now we do recommend the use of containment, booms, etc., to make sure that the cured material doesn't float off and have problems with that. But as far as contamination of water sources, you're good to go there.
Yeah, and on that note, we will be likely doing a single component webinar in the near future, so stay tuned for that. Our next question is, I've seen that these are used to stabilize excavations. Can you tell me more about that?
Yes, in fact, one of our contractors just did a pretty cool project that he sent us some pictures from yesterday, where they had an issue. They needed to excavate down to get to a pipe, and they knew that it was all gravel. So in this case, they used a dual component system to impregnate the gravel and create a box around the excavation area, held all the gravel in place. They were able to excavate down to the pipe and expose it for a repair and then backfill. The single component can also be used for those types of projects if the soils are right. The thing about single components is you have to have a soil that is a non-cohesive, sandy type soil that it's going to be able to permeate into. You're not going to push single component into clay, but your need for what we're talking about in this case with clay is not as high, and chances are the clay will hold itself up. But if you've got loose soils that need to be stabilized for excavation, then there's options both ways depending on the situation and the subgrade.
And on that note, I can tell you about multiple situations across the country where it was used to stabilize 57 stone that were sitting under, actually in both instances, under commercial foundations. They used it to stabilize the 57 stones, and in both instances, they were for new utilities, new storm drains that were being put in, along the street level. So they had to excavate the zone, and they were concerned that the gravel wasn't going to stay in place. And then, and they used the polyurethane to stabilize it. So both those projects, one was in Oakland, and the other one was in Durham. So, okay. Next question. How do you verify that voids have been fully filled under a slab?
That's a good question. And it's not the easiest thing to determine per se. Sometimes it's going to require additional drilling and witness holes and things like that. It's in everybody's best interest to make sure that we've got a good full void, that we don't have a bunch of gaps in it. But as far as verifying, unfortunately, one of the downsides, for instance, GPR, it doesn't really show up well on GPR. It typically still shows up as a void. So typically, you're going to have to do a little bit additional testing, and usually that's going to involve some drilling.
There are some, Tom, if you don't mind me adding on to that, there are some ways to being able to shoot to the point of injection, to rejection, where you start getting a little bit of back hit. That is another way, or doing laser monitoring where you're seeing a bump. But, to do a full on void, that's really tough. But that's more like the feel side of it is actually utilizing your equipment to help gain that knowledge. So, will it make precast joints watertight if applied correctly?
If applied correctly, yes. We have some systems that are designed for lining structures. We have a 7-pound foam with a spray system that has excellent adhesion. It's been tested on different surfaces, including corrugated pipe and wet concrete, dry concrete, brick or masonry. All these different surfaces because it was specifically designed for that infrastructure repair application. So it can be used to be sprayed on if you're injecting from the inside out and you're hoping for a good seal there. You're going to get a good seal there. The cleaner the joint, the better, but typically it's still going to expand it up and push all that stuff out of the way. So it can be used to seal up, joints that are a little bit, might have a gap there, and it'll hold up really well.
I just want to make a note. I've noticed we've got a couple hands raised. We will not be opening up the mics just because of technical difficulties. So if you can, please ask your question in the Q&A section. Next question. In addition to the product, do you also sell the installation equipment, drilling attachments, etc.?
We do sell the installation equipment from the standpoint of proportioners and rigs. What we call a rig can be in a box truck or a trailer. There are even some people that have done some skid mounted systems and things like that. We don't sell any drilling equipment. I've had the luck and experience of working with some projects where we use drilling equipment to get the delivery system down, but we don't sell any of that.
This is kind of a follow-up equipment question. I'm going to use that. Can our dual component equipment be converted and used for single component applications?
No. The short answer to that is no. Would it be possible to use one of those proportioning pumps to pump material? Possibly, but the equipment to do single component, it would be a huge hassle and potentially contaminate your lines and things like that. So the answer really to that is no. Single component equipment, though, is very inexpensive. The Terrapin cart is not necessarily mandatory to do what we do. Basically, a 1 gallon per minute airless paint pump is the primary tool that one would use to get into doing single component equipment or grouting. And so you don't really need to spend a ton of money to do that.
Excellent. So what would you estimate as your general cost for a simple sidewalk raising?
Well, everything.
And this is avoiding contractor minimums, that kind of thing. Let's just say on a per sidewalk basis.
That's a tough question to answer because, obviously people are going to have minimums and whatnot. As far as what it would cost somebody to do it, material wise, it's really not all that horribly expensive, but you also have a rig to pay for and all that stuff. That's kind of a loaded question. It's kind of tough to answer. So I think I'd probably leave that one there.
Yeah, it's on a per contractor, per region basis. Labor expenses are going to be different depending on the market that it's being done in. And then, if you have higher volume projects such as a city sidewalk or trip hazard mitigation, and you've got several instances of it, or in an HOA type situation, you can really get your costs down on a per volume. But it's really difficult for us to answer that, especially for individual contractors and what their numbers are. And typically, most contractors have a minimum that they're going to use. Thank you for the info. Looking for in-place compression modulus testing data in different soils.
Me too. So that is one of the challenges. You know, the testing that we publish is based on you know, free rise samples. We have done some testing on some constrained samples, but basically they're just constrained in a mold. So we'll take a 4-pound foam and put 5 pounds into a 1 cubic foot mold and then test that material kind of thing. That doesn't really tell us anything about the soils per se. There are just so many variables when it comes to soil to testing it that way, because you could have, you know, you could do shoot some in the ground and dig it up and do testing on it, but was that 1 blow count, you know, fill, or was it 8 blow count fill, or was it 8 blow count sand? You know, there's just too many variables and too many scenarios to have that testing, unfortunately.
Yeah, and we do a little bit of it with a single component on fine sands. You can find those on our TDS sheets for the 24-120 and the 015. But, you know, like Tom mentions, when you start getting into confined areas and then compressing those sands and stuff, our floral components become a little bit more complex. So I hope I answered that as well, if that was a good add-on there, Tom. Correct me if I'm wrong. I sometimes have to speak from a better position. So the next question, how is it estimated how much to inject to raise a slab so the slab does not get raised higher than desired? So I guess the question is how, yeah, you got it, go ahead.
It's as much art as it is science, is the reality. The beauty of the equipment, though, is that it allows you to make very small injections at a time, get the slab moving, and then kind of feather it into place with short shots. You don't have to say, okay, I think I need to put in 5 pounds to get this where it's supposed to be, and shoot until 5 pounds are in the ground. You shoot a little bit at a time until it starts to react and starts to move, and then you just put in little bits at a time until you get it where you want it. So again, it's as much art as it is science. And the guys that do this in the field and girls that do this in the field, it's you know, it's takes patience and time, but it's easy to it's pretty precise.
Yeah. And then, you know, I would add to that is we do have a cost calculator tool. It just generalizes math based on area, estimated void underneath, and et cetera. But, you know, that being said, if you've got a deeper void than what's typical in there, you're going to use more material. If it's lesser void than what's typically in there, you're going to use, you know, less material. So it's, you know, there's a little bit of art and feel, but there are some general calculations that can be used to estimate what the project's going to cost.
Yeah.
Any application in the SOF organic soils / stabilization? I'm not sure the SOF. Do you know what SOF is? Apologies.
Not sure. Not following that one.
I'll go do a quick search on that one, and we'll just move on. Are there testing tools available for contractors to test before and after compaction?
Available, yes. Cheap, not necessarily. There are some tools, you know, and some testing works better than others. The best testing methods that are out there for post inspection or post testing to see if you've accomplished what you've wanted to with deep injection projects and things like that, such as dilatometers. They're just not something that a contractor would buy. You're better off just having a company come in and test that. Or there are some small versions of dynamic cone penetrometers that are reasonably reasonably priced. But DCP is not a bad way to test if you can avoid any lenses of foam. But if you hit any of the lenses of foam, it's going to throw the test off. So with polyurethane, uh, you have that possibility that the foam can kind of lens off and follow that path of least resistance. So if you shoot on a 4-foot grid, doesn't mean that you're going to be able to take a DCP right in the middle in between those and not end up hitting some foam.
A quick search, SOF organic soils appear to be living soils. So that's soils that have their bioorganics in place, such as bacteria and things like that, that help, like, with minerals and vitamins, et cetera, for plant growing.
So
I think the general answer is no, or I don't know. You go ahead, Tom.
I mean, with the dual component systems, they don't really permeate the soils; they displace the soils. So you're pushing them in, you're pushing the dirt away. It's an inert product, so it shouldn't have any effect on those soils. Now, the single component would be a different situation. Single components are going to permeate the soils, and so that would probably have an adverse effect on that situation, I would think. Never been asked that question before, but that's my thoughts on the topic.
Yeah, I mean, the question is, has testing been done? I mean, I think theoretically that makes sense, but
I would say not to my knowledge.
okay. What is the deal with the channel lock pliers on the gun?
The clamps. So there's a couple of different systems being tested out there nowadays to avoid the use of the clamp, but the clamp is kind of a tried and true method. We drill a hole. We have packers, a couple of different sizes, but traditionally a 5/8 hole. We put the packer or injector into that hole. We use the clamp to attach to the injector, and then we put the gun down on there and clamp it down. So that's our mechanical connection to the injector. There are some new ones available out there that you can screw onto the front of the gun where you don't have to use that, but you have to keep pressure on the gun to make sure it doesn't blow out of the hole when you're doing it that way.
Right. I do want to say, out of respect, we have passed the 1 hour timeline. Please make sure that you fill out, the survey that comes either via email or close. But please hang around. We're going to finish all of these questions. We still have quite a few really great questions left, and so still some great learning opportunity to come. All right, I'm going to continue on. Can the product be used to create a waterproof curtain beneath the concrete foundation to prevent water intrusion into a basement?
Yes, if the soils are correct for it. If there's a gravel base underneath that slab or sandy loose soils, the single component could be injected to create a mat essentially underneath the slab. But it does need to be the right soil type. I've done just a personal experience installing a radon mitigation system in some of the older homes here in Knoxville where I live, and they basically poured the concrete slabs right on the clay. So in that particular case, you try to inject into that, it's not going to take the grout. So and if you try to use dual component for that situation, you're going to move the slab. So if the conditions are right, the answer is yes.
Yeah, and we have some contractors who very much specialize in utilizing single components to stabilize and seal basements or underground structures. So,
yes.
What is the deepest depth this can be used for?
Well, a lot of it is all about getting it there. We have some long running foam systems that can go, that can travel through tubing or injection pipes or whatever you want to call them for a pretty good distance. But getting the hole there, getting it drilled and all that stuff, that makes a big difference in what's been done. I would say that if you can get keep a hole open to stick a tube down in 100 feet in the ground, we've got foams that would run long enough to get there. Rarely are we dealing with situations where we'd have to go that deep. I mean, you have to think too about the what you're trying to support. I mean, is the load big enough that you need to go that deep? Typical deep injection projects, though, maybe I should say atypical. Some projects I've been involved with and have heard of, and know some of my colleagues have done, definitely down into the 30, 40, maybe even 50-foot depth for deep injection without any problems. It's really more about having the equipment to get the delivery system in place.
Well, if you don't mind me adding on to that a little bit, Tom, and I think this kind of goes back into the plural component systems as far as things you can do to make it react a little differently, such as temperature. Traveling a good distance at lower temperature is going to allow the material to travel farther. I've seen instances where we were injecting into trying to void fill a stormwater drain that had failed. And the temperatures outside were like 96 degrees. So getting travel with that kind of material is really difficult because the reaction of the material happened very fast. But I've also seen instances where we're talking about 60 degrees or something to that effect, and you can get really high travel time, especially the deeper you go. But I think your numbers of 30 to 40, that's the highest realms I've seen out there. So, okay. So next question, forgive me. Tools to test load bearing capacity before deep injection and after deep injection.
Dilatometer is probably one of the most popular. Again, this is something you're going to have to sub out typically. There's several others out there, but I think that's probably the most popular.
Yep. And I've seen some where they've done some deflection tests, and then they've seen some point load tests as well, but those were pretty significant jobs that I've seen those. Right. When you stabilize the soil, what does that mean for future excavations? Is it like digging up concrete? If you use the high density foam to stabilize soils underneath the roadway, or in the case of.
Sorry, Robert, I'm sorry. Say that again.
Oh, sure. I got to back up because I sort of, there's a tool that moves it. When you stabilize the soil, what does that mean for future excavation? So the concern is you go into a roadway, you stabilize the soil underneath it, and then they have to go back and dig that up.
Right.
What is that like?
Yeah.
Is there a concern, I guess is the question.
I don't know about concern. It definitely does make things a little more difficult. It's not easy to take a bucket of a excavator and be able to just cut right through it. It does have great tensile strength and shear strength, and so it can be cut. If you're trying to take a section out, probably the best way to do it is go through with a sawzall or a really long blade and start cutting it into squares so that it can be extracted a little easier. Because of those strength values, it's not so easy to just take an excavator and stick the teeth in and start pulling at it.
All right, next question. What is the best material to use for stabilizing extremely wet soils with very active clays in it? The office space slab that I'm looking at has a lot of constant movement with heaving and settlement.
Well, if you've got high moisture content, you definitely want to use one of the hydrophobic systems. If we've got clays, then we're rolling out the single component product lines. So depending on how deep you're going and what you're trying to do, the hydrophobic systems, such as 24042, 24003, or 044, those are all good options. But clay kind of rules out your single component stuff.
Could you discuss possibly using dual component product for low pressure systems, 250 PSI? What would you recommend, if any? Slab jacking only.
Um, with the low pressure systems like the small cart systems that are out there, if they use a static mixer gun, then you don't want something that's too fast. 24044 is probably a really good system for that application. It's slow enough to work with the static gun, but fast enough to do good concrete lifting work with.
All right, I've started moving closer to 24-inch spacing on my grid pattern when lifting with O&O to maximize void filling. Any thoughts on that?
Yeah, I mean it's not a bad idea. Obviously, the size of the lift can vary on how you want to do that and how much void you're creating. There's nothing wrong with it. I mean, if you were doing a 3-foot grid, uh, or if you're doing, for instance, a 4-foot grid with 24010, you would need to come back and void fill anyway. So tightening up your grid spacing, there's nothing wrong with that. You'll know if you're too close because when you drill in to do the next one, you're going to hit foam and it'll start coming up out of the hole. So nothing wrong with it.
And just for our audience that's not aware of our individual formulas, why is that question relevant to the O&O?
The O&O is one of our fastest systems. It is our fastest system, I guess, when it comes to lifting systems. And so you're not going to get as much spread. Um, Probably the most you would get on a good long shot is somewhere around an 18-inch diameter, radius from the hole. So that's why I kind of go with the 3-foot. But if you're doing shorter shots because you don't need to lift that far, maybe it's just down a quarter inch. Put too much material in, you're going to overlift. So by tightening up that spacing, you're still getting good coverage, and at the same time not overlifting.
Okay, great. I'm interested in Mechanil's properties of the materials of different formulas, components, so we can run some numbers in regards to strength or deformation. The Mechanil properties, apologies, that's a word that, yeah. If you don't mind, please, if you can clarify that question a little bit, that'd be helpful. Thank you. For a deep injection, what's your recommended injection tube size? Can you use a 1-inch threaded PVC?
PVC is not highly recommended for this, but I've shot through 1-inch tubing before. We typically like to keep it at 5/8 or 1/2-inch tubing. Less chance of it clogging up on you, I think, by doing it that way and building enough pressure to keep it moving. So PEX is a good delivery method if you're looking for something that's a little more flexible than metal. Obviously, metal is easier to drive into the ground, but if you're, for instance, doing say pipe abandonment or something, PEX works really well. And the packer system or injector system that we use can be used with PEX. Shoot me an email, if you've got any questions about how to do that.
Okay, and I did get a follow-up question to that Mechanil. Okay, what parameters can you use for soil treatment response or just injected material?
Say it again, Robert, I'm sorry.
What parameters can you use for soil treatment response or just injected material?
I'm still unclear exactly what they're looking for there. As far as the stuff that's on our tech data sheets, we not every system's been tested as thoroughly as some of the others. The ones that have been used for DOT work have had the most testing done because it's been required. But there we have compressive modulus and things like that some of the others have that data on.
Okay. Let me do a little handwork there I'll come back to that. So Any thoughts in coloring your product so it stands out from others? BASF purple?
We actually used to use a dye in the foam to make it kind of a grayish color. It's unnecessary, and I've actually heard that it can be detrimental to the foam, but not really sure on that part of it. But yeah, we kind of went away from it. It's kind of an unneeded expense, and so we just kind of left it. Most of it's going to be underground. I get it. If you ever needed to dig it up and see if it was your foam or not, then there's I guess, a valid point there. But typically, it's not going to get dug up.
Okay, so I want to back up to the previous question real quick. I think he's specifically looking for what properties are we using for our testing for the materials, such as compressive strength, modulus, tensile, et cetera. So maybe just kind of do like a quick review of what properties we're recording for the TDS sheets. And then if you can, if that doesn't answer, please, help us, we want to get to your answer there.
So here's some of the physical property testing that's done. The various ASTM test methods, compressive strength, compressive modulus, tensile strength, tensile modulus, shear strength and shear modulus, and flex strength, flexural strength and modulus. This particular system doesn't have it for the restrained sample, but for the free rise sample, those are the numbers for that. I hope that answers some questions. Again, most of these systems have gone through some basic testing. Some of them have gone through some more comprehensive testing. This particular system, 010, is our best seller. It's our most popular lifting foam, so it's been tested pretty good. But there's other systems such as the 003 here that this is used quite often with the DOT. So we've got, all that data from there. So if this doesn't answer those questions and there's something specific that you're looking for above beyond that, feel free to shoot me an email.
Yeah, and please feel free to send offline. We'll send a follow-up email. There was a follow-up that talks about soil treatment response into this, and I can generally answer in regards to it's really difficult for us to come to individual soils as far as what the direct densities and such that are going to be achieved, especially in a dual component systems, because the reality is that when you inject underneath a slab or when you inject into an environment that has like deep voids or issues with soil consolidation, the response, it's going to confine based upon the actual environmental situation that's there. And so, we have to operate, especially when we're talking about ASTM, within specific testing standards that allow us to have reliable data at the end of it. So that, I don't know if that helps, but there you are. Okay, so what is the range of pressures during injection?
So when we talk about pressures with this, if we're referring to what type of exerted pressure the foam is creating when it's being injected, that's going to vary a little bit from system to system. The somewhere probably around 15 psi. I've heard higher numbers depending on the system of exerted force that it's creating. But as far as the proportioner that's pumping this stuff, this is where there's a huge difference in equipment when it comes to this versus cementitious grouting equipment. We don't rely on pump pressure for this. We rely on the expansion of the foam.
Great. And then how do you know how much material is needed for a seawall fix and how much to apply?
So with the single components, we kind of have a general rule of about a half a gallon of material per cubic foot of soil that you want to treat. So depending on the design of the solution, if you're just doing like a curtain wall behind a 1 foot deep, from front to back wall, depending on how tall that is and how long the wall is that you're treating, about a half a gallon per cubic foot. Now it's going to depend on how tight those soils are. The looser they are, the more, the more it's going to take. The tighter they are, the less it's going to take. So really, voids play a role there and all that kind of stuff. But that's kind of our general estimating rule.
Here's a question. Is it better to use single component or dual in the water table?
It completely depends on the soils and the application. We can't lift with single components, so if it's a lifting job, that won't do us any good. If dual is the right system because of what you're trying to accomplish, then as long as you're using a hydrophobic system, then you're in good shape. Again, limited soils for the single component. You can't use it in everything.
And I would also add, depending on what the environmental conditions are in the local area, that we do have NSF certified systems as well that are hydrophobic.
Right.
So if you have environmental concerns, we have some materials that may be better suited. And this is just a general comment that a cone petrometer is a better test for evaluating soil load-bearing capacity for sandy soils and a quicker, cheaper method. So just a general statement. All right. And then one last one. Great Q&A, learned a lot. So that's it for our questions for the day. If you still have any questions, though, an email will be sent out post the webinar. Feel free to send us a note. We'll be happy to respond and, get you your answer. And we want to thank all of those that hung out with us all the way till 20 minutes after the webinar. I think it was an exceptional Q&A session, a lot of really great questions. So that being said, I want to thank you all for joining us. Stay tuned for our upcoming webinar events. We'll have some new subjects coming in. And then please, again, fill out the survey at the end. We really appreciate your time and your attendance. All right. Have a great day.
Thanks.